My name is Alisa Paterson. I am a research officer at the Sylvia Fedoruk Canadian Centre for Nuclear Innovation. The Fedoruk Centre supports researchers through grants to help place Saskatchewan among global leaders in nuclear research and innovation. We also operate the Saskatchewan cyclotron facility, which is where we are right now. A cyclotron is a particle accelerator that can be used to produce radioactive isotopes. So one thing we do is we produce fluorodeoxyglucose, or FDG, which we ship to the Royal University Hospital every day. We also have bookable workstations so that researchers can book things like our small animal PET-CT and hot cells, such as you see here, to do their own research as well. We produce radioisotopes for researchers as well to help advance research in nuclear science, medicine, agriculture, health. As a research officer, I serve as a local contact for researchers who might want to use the facility or book our workstations, start projects using the Fedoruk Centre. I also lead internal projects to develop our capabilities or improve our capabilities and processes. So for example, one project I'm currently working on is to help develop and purify a new radioisotope that we could add to our catalog of radioactive isotopes that we can supply to our researchers. Some of our radioisotopes are produced by hitting a solid target with a proton beam. And then once we have that solid target that's been hit by the proton beam, we need to extract the radioisotope from it. So dissolve it in acid and then remove any impurities from it, and then present your final product that the researchers can use in their research. In research, there's not really a typical workday, so I could spend one day reading literature to see past research that's done to inspire my own research. I could spend a day doing experiments. I could spend a day analyzing data from experiments I've done. So there's a lot of variability in the day-to-day. Since high school, I've always been interested in the STEM fields, and I always did well in my science classes. So I did a bachelor's degree in chemistry, and during my bachelor's degree, I joined a co-op program where you can gain work experience as you're doing your bachelor's degree. So I also worked in some labs during my undergraduate degree. I worked in some routine analytical labs. I also worked in academic research labs, and I worked at a pharmaceutical company for a while, and those experiences led me to wanting a career in research. So then I decided to get my PhD in chemistry. Then I held 2 postdoctoral positions at 2 different universities, and then I moved to the Canadian Light Source, and then I was a beamline scientist for a while there. I did my bachelor's and PhD in chemistry at Simon Fraser University. My first postdoc position was at North Carolina State University. My second postdoc position was at the University of Calgary. During my PhD, I got exposed to synchrotron science, and then I met my first postdoc supervisor at a conference, and he does a lot of synchrotron research. In the goals of maybe one day working at a particle accelerator, I thought that working with a professor that does a lot of research in that area was a good idea. In the research field, an important skill to have is problem solving, because you're going to try experiments that are not going to work, and you're going to have to try to figure out why and what you need to do to make them work. I think teamwork is also important because you work in a team, you're working towards common goals. Organizational skills are always important. You have to keep track of all your data and be able to analyze it and present it in a way that makes sense to other people other than yourself. I enjoy that my work is not very predictable. It's not going to be the same thing day in, day out. I enjoy the sense of discovery, and I enjoy the sense of accomplishment when you figure out how to do something you've been trying to do. In the sense of supporting researchers, it's fun to see researchers that use our facility learn to use our equipment and then go on to produce big scientific advancements. I think the job market in the research field can have a lot of opportunities. You just really need to think about how transferable your skills are, because For example, I was trained as a solid-state chemist. I moved into synchrotron science. I did agricultural research, and then now I'm doing nuclear science. So even if you're trained in one specific area, you can apply those skills to do research in many other areas. Like, for example, if you've done a PhD, you've shown you're capable of doing independent, like, productive research, and you can learn. I think it's important to find good mentors that can help guide you through your career. I've gone back to my past supervisors to ask them for career advice in the past. I think if you are interested in working in a lab setting, I think it's important to maybe during your training to volunteer or work in labs, just to expose yourself to the environment and make sure it's the kind of thing you really want. And then as you do those volunteer research experiences, you can learn what kind of field you might have interest in.